In this video, we're going to have a look at the probability of compound events. Up to now, we had a look at simple events. For example, flipping a coin. A compound event consists of two or more of these simple events. For example, we can take the flipping of that coin and repeat it a second time. Or we can combine flipping a coin and rolling a die. Then, of course, there will be a lot more possible outcomes than for an original simple event. Ease your calculations, these outcomes can be represented in two possible ways. Firstly, a two-way table that works for two events, and then also a tree diagram that works for even more than two events. Let's go and have a look at some examples. Example 1. Suppose a coin is tossed twice. First question, represent the possible outcomes in a two-way table. To complete a two-way table, you will write down the possible outcomes for the first event vertically down and the possible outcomes for the second event horizontally. In the middle, we'll then find the combined possible outcomes when both events happen. So, when flipping the coin the first time, we have two possible outcomes of heads and tails. And then when tossing the coin a second time, we again have the same two possible outcomes. Once both coins have been tossed, we have the possible outcomes of head and head, or head and tails, or we can have tails first and then head, or finally tails and tails again. From this, we can see that there are 4 different possible outcomes for tossing a coin twice. Question B. Determine the probability to get tails followed by heads. From the table, we can see that there's only one outcome, giving you tails and then heads. This probability will be 1 out of the 4 options. Question C. Determine the probability to get at least 1 heads. At least 1 means it can be either 1 or 2 heads. Here there is no specification whether it should be the first or the second toss. This means that both results can be heads, or only the first toss can be heads, or only the second one. So the probability of getting at least 1 heads will be 3 out of the 4 options. Question D. Now represent the possible outcomes in a tree diagram. A tree diagram consists of different branchings. Each new branching represents the possible outcomes for a specific event. So in this example, our first branching represents the first event with 2 possible outcomes. Because we had 2 possible outcomes, our second event will be represented by 2 different branchings. The first branching for event 2 will happen after event 1 took place in the first possible way. The second branching has the exact same 2 possibilities, but they will take place after event 1 happened in the second way. If there would have been a third event taking place, we would have added more branchings at the end of each branch of event 2. In our example, there are only 2 events, both tossing a coin. So our first event has 2 possible outcomes, and that is either heads or tails. The probability of getting a heads on the first coin toss will be 1 out of the 2 options, and the same probability will be true for getting tails. Please note that the sum of the probabilities of one branching should always be equal to 1. Now we add event 2, and we start off with the possibilities after event 1 landed on head. And again here, the possible outcomes will be heads or tails, and for each of them the probability is a half, because the result of event 1 does not influence the probabilities of our second coin toss. And once again, when you add up the possible outcomes probabilities, it equals 1. And finally, we add the second branching for event 2, and that will take place after event 1 landed on tails. And again, our two possible outcomes will be heads or tails, with both having a probability of a half. Here we now have the possible outcomes for the compound event. And to get these possible outcomes, we start right at the beginning and we follow the different branches. So our first outcome will be heads and then heads again. Our second outcome will be heads and then tails. The third outcome will be firstly tails and then heads. And the fourth outcome will be tails and tails again. So now we can see that there are 4 possible outcomes for the compound event, and these are the same 4 possibilities that we listed in the two-way table earlier. Because each one of the branchings had exactly the same probability, we can say that each one of these possible outcomes have a 1 in 4 chance to happen. When the different branches have different probabilities, the different outcomes will also have different probabilities to happen. And this is what we'll have a look at in the next video.